So the big picture for this lesson is the law of sines. The law of sines is developed from the area of oblique triangles, and the lesson shows how to do that. For this video, I'm just going to explain how it's used. So the basic idea is that for any triangle, the sine of the angle divided by the side opposite is the same ratio for all three. So sine of A over A, sine of B over B, sine of C over C, those are always equal ratios. So you can use this proportion to solve a triangle. And it only works for certain criteria though. You need either angle, side situation or angle, side angle. Also there's the side angle, which can lead to maybe an ambiguous case where there could be no possible triangle, one or two triangles using the law of sines. So side angle is a little more complicated. So basically all you do is you determine what your situation is, and then you go ahead and use the law of sines and maybe the triangles to solve triangles. So for this one, let's say C is 37 degrees and side C is 5. And then let's say angle B is 41 degrees. So this is an angle, side situation, which is law of sines criteria. So I'm going to say sine of C over C equals sine of B over B. And it really doesn't matter which letters you use, A, B, and C. You just need to know that the side and angle opposite each other are in the same ratio. So for this one, it'll be sine of 37 degrees to 5 equals sine of 41 degrees over B. And you can use this to solve for side B. Then you can use the triangle sum theorem. You subtract 37 plus 41 from 180. That'll give you angle A. Then you can use law of sines again to solve for side A. And there are a lot of examples of this in the lesson, so you want to make sure you study those and watch the videos. Now side angle, sometimes you can have two possible triangles. So let me sketch out a side angle real quick. Okay, so let's say you're given this side is 9 and this side is 10 and this angle right here is 64 degrees. This is side angle. What happens here is this could actually form two triangles, because what you could do is you could go like this, and this is 10, so then you could have another triangle here with the same side angle criteria. So that's why side angle is a little tricky. And so what you can do is you can determine how many triangles you have. So here's the criteria for law of sines for side angle. What you do is you use h equals b times the sine of the angle A. What you do is you use your given angle measure as angle A. And then b is the side not opposite angle A. So those are both given. Now based on this side that's opposite angle A, that's how you determine how many triangles you have. If the given side A is less than the height, which is h equals b sine of angle A, no triangles can be formed. If side opposite the given angle is longer than the other side, one triangle can be formed. If the side opposite equals the height, then you formed a right triangle. However, if the side opposite is greater than the height but less than side B, then you have two triangles that can be formed. And you can see how that works. You would have this tiny triangle here, and then you'd have a larger triangle for B2. So for this lesson, you're just going to be determining the number of triangles that can be formed for the ambiguous case. The next lesson, you're actually going to solve those triangles. Okay, so that's the law of sines.